So in this question, two parallel conducting plates are there, separated by a distance d. A potential applied between the plate and the charge q is there, is halfway between the. Which of the following give the magnitude of the force? So first thing, we know this. What is the formula for strength of electric field between the parallel plates? The strength of electric field is a voltage divided by distance. That's a formula. And we know the strength of electric field E is equals to F over Q. So if I need the, so in place of E, I can substitute F over Q. So this E is there, so I can write F over Q is equals to V over D. Because we know the strength of electric field is constant. If charge is placed anywhere, even the same question, they can place the charge anywhere, but the strength of electric field is same throughout. So I can say F over Q is equals to V over D, but if I need the F, so what is the value for F? F is equals to VQ divided by D. So VQ divided by D, so it matches with option D, or D will be the right answer for this. Is it clear, this one? This is about the capacitor. Question 10. What could be the answer here? Use the chat to answer. In question 10, two charged spheres of equal masses. So they have the equal masses. The mass of the charged sphere is same. Are with insulating two charges are placed. Equal masses are there. Insulating thread of equal lengths. Okay. Which of the following show the arrangement of the sphere when they are in equilibrium? Equilibrium means when they are balanced. First thing, the force will be same between them. Why? Even though, because we know according to a Coulomb's law, if there is a charge Q and this charge 10Q, okay? So the force between them depends, F is equals to K Q1 Q2 over R square. So means if the resultant force is 30 Newton on this one, the resultant force will also be 30 Newton on this one. So both will have the same resultant force, but in opposite direction, but the magnitude will be same. And in the question they said, they give us that both have the same masses. So if I have like example, if this is 2 kilogram and this is also 2 kilogram. If this 2 kilogram experience a force of 30 Newton and this also experience a force of 30 Newton, even though this charge is Q and this charge is 10Q, but their mass is same and they have the same force on them. So they will have the same displacement from the mean position. That is why C will be the right answer. If the masses were different, like example, the one which is greater mass, let's say, if we change the question, one is 2 kilogram, another one is 10 kilogram. So the 10 kilogram will have a less, force will be same on both of them, but the acceleration or the change will be less for the 10 kilogram. If this is experiencing a 30 Newton, this also experience 30 Newton. So in that case, the displacement of the 10 kilogram will be less as compared to displacement of, a displacement of 2 kilogram. So the displacement from the mean position, because when they were not having a charge, the two spheres will be touching each other. So this is 2 kilogram. This is also 2 kilogram. And they're touching each other. But once we give a charge, let's say we give a charge Q to this and we give a charge plus 10Q to this. So as a result of the charge, there will be a force. If this experience a force of 30 Newton, this will also experience a force of 30 Newton. This 30 Newton cause a displacement or acceleration or change from the mean position. So as a result, because the movement from the mean position depends on the mass and the force, because we have the formula F is equals to ma. Even though even if I change the magnitude of the charge, I call that as a 50. The answer will remain same. If I write this as 100 coulomb, the answer will be same because the masses are same. That's why they will have the same acceleration. If the masses were different, then they will have the different accelerations or different displacements. Is it clear? So the displacement from the mean position depends on their mass. And if we have two charges of different magnitudes, the force, according to Coulomb's law, if there is a charge of a 2 coulomb and there is a charge of a 5 coulomb, according to Coulomb's law, the force of repulsion or attraction will be same. If this experiences a 30 Newton, this will also experience a force of 30 Newton. But the displacement from the mean position depends on their masses. If the mass is same, like if this is 1 kg, this is also 1 kg, so their displacement from the mean position will also be same. Is it clear? Discussion that why C is the right answer? Which graph shows electric field strength due to negative point charge? Negative point charge. We did that, like we sketched the graph for electric field and distance for the point charges, for the charge sphere and electrodes. Use the chat to answer. If you remember the graphs, I sketched three types of graphs. One was like this, electric field and distance. Another one was like this, electric field and distance. And the last one was like this. So this is for a point charge. This is for a sphere, the charge sphere. And this is for the plates, the parallel plates. So we want a point charge, so means this, it should be from this one. So this is for positive charge and this is for negative. That's why D will be the right answer for this. Is it clear? Question 13. When we have the two charges are there in the question, the two charges, what about the electric field? As you can see, when we draw the electric field lines, the electric field lines are pointing out from positive and into negative. That's a pattern we draw. And remember one thing, if the spacing between the lines increases, it means the strength of electric field will decrease. And we have the formula E is equals to F over Q. So if the strength of electric field is decreasing, the force will also decrease. So what will happen as we are here, this is the distance between the lines. As we are here, distance between the lines. As we are here, distance between the lines. So at this point, the distance between the line is maximum and then again start to decrease. So first, as we are moving from, like, let's say this is point A and this is point B. So first, when we are moving from point A to X, so what happened to the strength of force? The strength of the force will decrease. And then what will happen from point X, the strength of the force will increase. Because the space between the lines shows the strength of electric field. If the lines have small space, the force will be stronger. If the distance between the lines is less, it means the force is stronger. If the distance between the lines is greater or large spacing between the field lines, so then what will happen? The force will be weaker. So as we move from plus Q to negative Q, what happened? The first strength will decrease and then the strength will increase. So at point X, we want, what about the resultant force at point X? So resultant force at point X will be minimum. It will not be zero, it will decrease, so it will be minimum. And what about the direction? The direction of electric field, as you can see, the resultant direction remains same. That's why the direction is not changing. Or the resultant force is not changing a direction. Or resultant force is not zero as well. If the resultant force is zero, what cases the resultant force is zero? If the spacing between the lines, like if we have like charges and there are no field lines there, when we draw the electric field line, so that's how we draw the electric field line. So if there's no electric field line, at this point, the force will be zero as the electric field strength is zero. But for opposite or unlike charges, we draw the electric field lines out from positive and into negative. So the spacing between the lines shows the strength of the field. As you can see, when we move here, we have a small spacing. So means the force is stronger. Force is getting weaker. Then the force is the weakest or the minimum. And then again, the force will start to increase as the spacing between the lines is decreasing. Is it clear? So the spacing between the electric field lines shows the strength. So that is why, like if we have a point charge is there, if we have a point charge, a positively charge is there, and we draw the electric field lines. So when we draw these electric field lines and we say we are moving, like example, we are at position Q and we are going away. So what we'll say, what happened to strength of electric field? It is continuously decreasing. Why? Because when you compare the space between the lines have closely spaced, then the space between the lines increasing, so the strength will decrease. So these are some MCQs related to the topic. More we'll do the next session.